today I'm going to introduce you to a new product that Zerto currently has in beta that's going to be aimed at protecting EC2 instances between regions and zones in AWS. And we're calling it Zerto in Cloud for AWS. And this is going to be aimed more towards, well, I'll lead you down that road. I don't want to give too much away yet. Before we start, my name is Gene Torres, and I'm a technology evangelist at Zerto. I've been working as an IT pro for about 21 years now. I've been with Zerto for 4, prior to that, 2 years as a customer. So I guess you can say I love the technology so much that I came to work for Zerto. So I started as an SE in the Pacific Northwest, and here I am now. Before we begin, you guys are aware, please feel free to interrupt me anytime, ask questions. This is still in beta. But so far from what I've seen, it works great. Any questions you have, I would love to hear them because it is in beta and these might be things that we haven't thought about yet. So that's that. So what is Zerto in Cloud for AWS? So we're calling it ZIC for short. And while we have had a great solution for the past 6 years when it comes to DR to or from AWS, we needed a different approach when it came to in-cloud protection, especially at scale. So the ZIC is going to bring simple, efficient, and quick workflows to address the challenges of in-cloud disaster recovery and with the same look and feel of the current product. So from what you saw in Heis's demo, the interface, the workflows, et cetera, very similar. So for customers that have migrated into AWS that want to then use Zerto again to protect between regions and zones, very similar experience. So we'll dig into the details here shortly, but as far as availability of solution, again, it's currently in beta. We've got several existing customers who have migrated to EC2 and are working with us to test it all out, meeting with them regularly, getting feedback. So we're targeting the release for later this year, Q4 to be specific. And what it's going to give us is the ability to do live failovers or failover tests like we saw previously with Heis's demo. But we're going to be able to do region to region and zone to zone, because we know that within each AWS region, there are several data centers that they call availability zones to kind of separate the workloads, provide HA capabilities. But then the trouble with having multiple data centers is they need to be within a certain distance of each other. And typically they're about 60 miles from each other. So a whole regional outage, they typically all go down with it. So we need to be able to get out and then also take advantage of the additional HA capabilities in the recovery regions as well. All right, so I mentioned the region to region and zone to zone. This speed and scalability is really what we're aiming for here. With speed, it's the speed to protect your machines, right? Because in AWS today, you can do this manually. You can take EBS snapshots of all your EC2 instances, and then you can replicate them to another region. But what it doesn't have is the orchestration piece that just makes it simple and easy to adopt. So we're really focusing on the speed and scalability when we're aiming on GA to at least support 1,000 VMs or instances in AWS from the start. Again, target GA is Q4 of this year, so be on the lookout for more information. I'm sure we'll share it with everybody out in the world once we get closer. Okay, so the Zerto in-cloud appliance is our first official Zerto manager that will be Linux-based. Because today, currently with our on-premises offering, it's our Zerto Virtual Manager, it runs on Windows. And in the cloud, we have our Zerto Cloud Appliances, which also run on Windows. So this is going to be our first step into a Linux-based appliance, if you will. And the way we're building it is that it's going to leverage several already available open source solutions that have been in the market for some time and in use out in the wild. So these are all mature solutions. Again, we're not recreating the wheel here, because these solutions on their own are already pretty powerful and in use with many organizations today. For example, on top of Linux, we're running Docker, which houses containers for the rest of the solution. And all these logos you see here are part of that solution. We're using Keycloak with Postgres for identity and access management. RBAC is something that's been important to our customers. So instead of recreating all that on our own, we're gonna lean on something that's already out there that folks may be familiar with already. We're using Traffic for container networking simplicity for the reverse proxy, Nginx to host our GUI. So Zerto in Cloud is being designed with the extensibility and agility in mind. And as future updates are released, it's as simple as a one-line command line entry to pull the new container down or container updates down from the repository. So it's very quick, very easy. I've actually sat on a meeting with a customer recently while they were going to the latest build, and it was just simple like that. It took less than a minute to get the updates. So it's very friendly for especially for those who are automating. And this is also going to introduce non-disruptive updates for the most part. So additionally, about the automation, a lot of customers are mentioning they're using stuff like Jenkins or Ansible. So the approach here we're taking is still it's there to enable the use of their existing technologies to align closer to their management of their environment. So I mentioned Keycloak is going to offer I'm just going to build this all out. Manage their identity and access management, but it's also going to bring the capabilities of multi-factor authentication capabilities to Zerto as well. So all of this is designed taking advantage of Amazon's existing APIs and their capabilities along with the native services. So we use DynamoDB to track our configuration and our journal checkpoints. So I'm seeing this as an orchestration engine for the cloud. So we're going to start with AWS, and I have heard the next step is once we've solidified this with AWS, we're going to turn our sites over to Azure and work down the same road. Okay, so just a quick, I do have a recorded demo to show you guys what this actually looks like. But before that, I kind of wanted to give you the lay of the land, if you will. So what I've got and how it works is I've got my protected region, which is US West 2 or Oregon. And within their region, they've got 4 availability zones. I've got 5 virtual machines. They're all just web servers. And then my recovery region is in Ohio at US East 2. If you can see on the right side in the recovery region, that's where I put the Zerto in Cloud Linux appliance. And that's for good reason, because if I put it in the protected region and that region goes down, I can't recover my data. So we put it in the recovery region. First thing we're going to do once it's all installed is we're going to create virtual protection groups. The same look and feel workflows as Heis's demo, and you'll see it in the video here I'll play shortly. So we'll create the VPGs. After we create the VPGs, we're going to start that initial sync. That initial sync is going to kick off a full snapshot of all the systems. So I've got my first VPG that contains these 4 VMs, and then my second VPG with a solo VM in it. But what's interesting with our consistency as well is we're going to be able to take snapshots of all the machines in the protection group simultaneously. So you're going to get that consistency across all the disks in that point in time. So we're going to hit EBS, Amazon EBS, give it the snapshot command. We're going to create the snapshots for both VPGs. We're going to replicate those snapshots to Ohio. And once it's there, I want to run a failover test. So I'm going to go through that same workflow. I'm going to hit failover, select test, and then it's going to, Zerto is going to create the EC2 instances. They're going to power up automatically. They're going to shut down because we need to now attach those snapshots to those disks or those instances. We'll mount the EBS snapshots to those, and then we'll power them back on. We can also still do the same things like re-IPing and then selecting specific networks and security groups for these machines. Typically in a test environment, as mentioned before, we do want to have an isolated environment because we would like to do non-disruptive testing in most cases. So all it really takes to do that is to create a subnet or set of subnets. And you do need one or at least one per availability zone if your targets are going to be different zones. And then security groups to make sure that nothing gets in, nothing gets out, except for what is required to test these machines. When you're done with the test, everything looks good. You just click stop in Zerto. We're going to reverse everything we did. We're going to shut down the instances. We're going to unmount the snapshots and remove the instances. And the whole time we're doing this, we're still replicating data. Now, one of the interesting things that differ from what we have on premises today with our continuous data protection is in that offering, we don't have the capability to actually set RPO. We can set alerts on RPO, but not the actual, like, I want checkpoints created every 5 minutes or every 30 seconds or something like that. It's all dynamic. Because we're using snapshots on the Amazon EBS snapshot engine and APIs, we can actually set RPOs according to SLAs that the business defines. So if I want my first web application to have an RPO of 15 minutes, I set that 15 minutes, and then every 15 minutes, automatically Zerto will kick off a snapshot and replicate that set of snapshots to the recovery region. And then same thing for the second one. I want 30 minutes, I can do 30 minutes.
What's the quickest RPO you can do with this solution?
Right now, according to our product team, because they're testing, they haven't gone below 15 minutes yet. Because if we're talking at scale, there are limits to number of snapshots within a region per user, et cetera, concurrent snapshots, and then concurrent replication of snapshots. So they are working on the scalability portion, and that's going to be that's the primary target right now for GA, is to hit that 1,000 mark. And they have expressed that they will test 1,000 VMs live, like actual VMs with data on them. So that's still being worked on. And they're doing it in an interesting way because there are limitations per account, per region. They're looking into the possibility of maybe defining based on the, we're going to have to calculate how many disks, how many systems, to be able to auto create, if we can, additional accounts to then run or use those on behalf of Zerto to get the additional scale to do that. And then when it's done, it'll spin them down. But yeah, that's what we're shooting for at first. But 15 minutes, I have tested 15 minutes and it works just fine for these 4 machines. In fact, I should go lower, see what happens, right? Because they all are single disk machines. So that was a failover test that we just saw. In a live failover event, it's a little different, right? Because it's now live. So we've completed all the initial steps. We've created our VPGs in this scenario. They've been replicating for some time for that ongoing protection at those intervals. So first thing we're going to see is, one, there's a regional outage. It could be an availability zone outage. It could be a network outage. Someone could have removed the wrong EBS data stores out there, because that doesn't happen, right? So they could effectively take a whole region down. Human error is going to be like the top on the list there. So we're going to simulate a complete failure of this region. So the first thing we're going to do is, obviously, we declared an outage or disruption to the business. So we're going to initiate the live failover, and the workflow is very similar. We're going to create the instances again. Zerto is. Zerto's going to then shut those instances down, mount the snapshots, power them on, and then we'll have that. We also have that commit policy default to 60 minutes, so the operations team or the administration team can get in there and they can verify everything works. If systems today we don't have the auto elastic IPs or anything to attach them, so little steps like that will have to be performed. We are working toward more of that automation to pick up on some of that stuff. To make it a lot simpler. But they're going to go validate everything, make sure the application works, make sure the data's there, give the thumbs up. We're going to commit it, and then you're effectively failed over and running production in Ohio at this point. Now, when the primary region, so when Oregon's region comes back up and is available again, we don't have the auto protect just yet because it's still pretty early, but you effectively, in the current build right now, you would just recreate those VPGs and send them out back in the other direction. It's just not automated yet. It's still pretty early. So with that, I'm ready to jump into the demo here. And this is recorded, so you can stop me at any point and ask questions. I'll pause it while we do that. All right, so here is my Oregon region here. I've got those 5 machines, the same ones that were outlined in the diagram. So it shows they're in US West 2. And there's my Zerto in-cloud appliance. So the only thing different here is I didn't build the ZIC in Ohio. That was done afterwards when I built the slide. So this is actually running the ZIC in Oregon right now, along with the production workloads, which is, I wouldn't recommend doing it, but it is a test lab. So this is just showing that each one of these systems have Nginx running on them for a simple web page to simulate my web application. Right, so it's all 5 of them. And one of the things I want to mention about the way Zerto in Cloud for AWS is built is it's built with the CLI and automation first, API and CLI first. Runs on a bunch of bash scripts under the covers. So I'm going to show that to you. I'll create a VPG with the command line, and then I'll also create a VPG using the user interface here. So here's my Ohio site. You can see nothing's running, so there's no smoke and mirrors or anything. No instances here. Okay, so we're going to first create a VPG to protect UB05. It's going to be a single VM VPG. When you're automating, you can do a lot more. I did this all manually by hand, so in the command line. And how it works is you get a JSON file with all the fields, so you'll have the structure available. Customers will have that, and they'll be able to fill those fields out automatically if they want with the script. But these are all the queries, and these are all the bash scripts and commands that we have available today, right now. So typical stuff to list all the virtual protection groups, get me all the tasks that are running, the top tasks, etc. And then also do some discovery about my regions, my protected region, the VMs in there, the subnets, security groups. And so you can basically create a script to read all that information and then dump all that information into the JSON file. And then I just heard this morning that we are supporting AWS tags as of the latest build today. So, that I haven't done yet, haven't installed yet. So then you can further pull tags and use those tags to create the VPGs and grab specific VMs or instances to attach to or group into those virtual protection groups. So we can do everything from the command line here that we can do in the GUI. It is built with API and command line first, because when you're automating, that's the preferred way to do it. So let's continue on here. I've already filled out the JSON file for this one VM with my protected and recovery region information. So again, this is just showing you what operations we have available right now. And I can expect this to grow as we build more features into it. There's my JSON file right there. So I'm just going to create the VPG. It's a single line. I'm going to tell it to create the VPG using this JSON file. So the script is then going to read the JSON file and create the VPG with those settings. And then we'll go through the GUI and I'll do the same thing so you can see what that actually looks like graphically. So that's it. It created the VPG. It's automatically syncing it. So it's taking that initial full snapshot of the virtual or the instance. You can see when I kicked it off. And initial sync will take place right now. And again, there's nothing running yet there because we haven't initiated a test or a live failover. So back in here, I'm going to now create that second virtual protection group with the group of VMs, the 4 that are spread between the other 2 availability zones. And I couldn't figure out what to name these. So forgive my indecisiveness here. All right, so again, just to reiterate, the ZIC can live anywhere. So it doesn't have to live in the recovery region. It can live in an entirely different region from everything to get be a little more resilient. So what's different from what's on premises is now we're seeing the region. So what region do these VMs live in? So we're going to select the Oregon region, and it's going to list the VMs at the bottom, everything except for the one we just protected. Okay, so we just select all 4 of them, move them over to the right to the protected list. And then here we're going to choose our recovery region, which is going to be Ohio. And so here we're going to set how much history in the journal do we want to keep? We'll just keep a day since it is just for demo purposes. And then the second field is where we set let me back up just a second there. So you can see that. That second field is where you're going to set the RPO. So every 30 minutes for this VPG, I'm going to create Zerto's going to create a snapshot and replicate the incremental snaps over to the Ohio region. And then I have an SLA, right? So my RPO alert, if I exceed 30 minutes, or in this case, if I exceed 1 hour, I'm going to get a notification from Zerto that says, hey, something's wrong. You're not meeting your SLA. Please go take a look and see what's going on there. So let's go next here. Now we're going to choose the virtual private cloud network for both failover. So this is live failover on the left, failover test on the right, which is then you select the subnet according to the VPC you choose. And then, so in order to get the different availability zones and divvy these all out is you need at least 1 subnet in each availability zone to be able to disperse them. So you'll see I'm not going to be able to click it here and choose it, but you'll see for the failover test, I believe it's going to be a different availability zone. So that's going to be my production subnet, which is in US East 2C. And then I've got on the right, my isolated subnet is in US East 2B. I've got my security group here for lab access. This is my production security group that gives me port 80, 443, 422 for those Linux machines, so I can get access to it. And then my failover test network is going to have the isolated security group and subnet. And I really do a good job at highlighting, what we're talking about. So isolated there, so nothing comes in, nothing comes out. And I'm just going to show you here that if I do need to change or set specific availability zones or subnets per virtual machine, I can then do that at this level here. The previous screen is just the defaults for everything, but if you do have requirements to geographically separate these 4 machines because they are load balanced, then we can get them out of harm's way and make them more highly available by selecting different zones. And then here's where we can re-IP if required. And I'm not going to do that because my EC2 and networking, when I built this in this demo, were not full-fledged created and fully networked. So we can set our production IP address or our failover test IP address on the right. And you could do that per instance. And then we're going to get a nice little summary here. So right now we're showing the recovery settings for production failovers or live failovers. All the details, what we're doing here, what the VPC is, what the subnets are, etc. And then if we flip the toggle switch over to test, you'll see everything that's associated with the test configuration. It's my RPO settings, my journal history, my alerting, my VMs that I'm including. And just like Heis's demo, we create the VPG and then we instantly kick off initial sync, create those snapshots, get them replicated over for the initial seed. And then we go into effectively enter into continuous mode. And at that point, it just happens at the intervals that we set. So the 30 minutes and the 15 minutes between the two. How are we doing for time? I can speed this up a little bit. Don't want to wait for that paint to dry there. Okay, so now we're meeting our SLAs. I've got RPOs of 5 minutes and 14 minutes right now. And that's going to climb because we're not continuously protecting these. They are on those intervals. So they're going to get up to the next snapshot being taken. That's going to be our effective RPO. So I'm going to, I don't know if you guys caught that. So I'm going to initiate a test failover for that single, or I think it's a single VM. Yep, 05. So very similar workflows here. I can choose a checkpoint, just like we can with the on-premises and on-premises to cloud product. And then we're going to start that failover test. So here's where the workflow that I showed earlier, where we create the instances and then we shut them down. We attach the snapshots to the instances, takes place. And then we'll power it back on. Because my isolated network, I didn't set up a way to get into it. Luckily, AWS gives you this nice little screenshot of to see what the instance looks like after it boots. So we're just going to take a look, and this is just a quick peek into, did it boot? Is it ready for login? Very quick and dirty validation here. Typically in production environments or organizations will have actual processes to do all this. Their networking and plumbing will all be there to be able to get in there, whether it's a jump box or a VPN into that network. So I stopped the test and it's going to shut it down, delete the instance. And then what I'm going to do next is I'll run a live failover for those 4 Nginx, the other 4 servers. So you can see there it's auto terminated. Okay, so we're going to go to failover. This time we're going live, and you can distinguish because when it's live, we get that red bar. So it's a great visual warning that what you do here is the real deal. So we've got that outage in Oregon. Well, it's hard to say that right now because my ZIC is in Oregon. But according to the diagram, we have that outage in Oregon. So I'd effectively be logged into Ohio or any other region that we put the Zerto in Cloud Appliance at. And that same process is going to kick off. We're going to create the instances, shut them down. You can see them stopping. This is where those snapshot disks are attached to each one of those instances. Then they'll get powered back up. All right, so 1 is up. Okay, everything's running now. So the failover, we've validated everything. I can either roll back at this point if it didn't look good, and I can try it again with a different checkpoint. Or if everything looks good, I can click the check mark, commit it, which makes them effectively permanently live and running production in Ohio. And then because I mentioned we're not able to auto apply any the Elastic IPs for the public access, I went ahead and did this behind the scenes. I just attached it to 2 of them to then be able to bring up the web pages to show that they're working. right, so there's 2, and then we'll change, switch over to a 1 here. So yeah, there you have it. There's still some work we've got to do in there, but it's effectively working for the failover test and the live failover. Again, this is going to be aimed at those customers who have either built instances and run production in the cloud in AWS today, or they've gone through and used Zerto, our traditional Zerto offering, to the cloud to migrate those workloads in and for production migration. Because that's always been the question is, all right, so you guys can move us in, but what happens next? How can we be protected? And this is to answer that question. This is how we can protect you. We're going to use native services. We're going to make this scalable, make this fast. We're going to give the same look and feel as what you're used to in the product that got you here in the first place. It is different from what we're doing, not only because it's Windows, it's just the whole process behind the way we do things with our Zerto Cloud Appliance is different from this. So what I have seen and experienced with this version is it is a lot faster.